Type 2 hypersensitivity reactions are a type of unwanted immune reaction caused by antibodies recognizing antigens on normal cell surfaces. Antibodies attaching to our normal cells results in an autoimmune attack by other parts of the immune system, or impaired function if the antibody binds to a receptor. In this video, I'll share my visual mnemonic to remember all the key details about type 2 hypersensitivity. The sports scientists are joining us on the football field today, where we are using these special shoes to measure our kicking ability. Do you see the sensors on these shoes? These sensor shoes are full of sensors that measure speed, acceleration, and other metrics of an athlete's ability. By the way, the sensor shoe is also our symbol for type 2 hypersensitivity. Get it? We're using a sensor to represent hypersensitivity, while the shoe is our recurring rhyme for the number 2. Type 2 hypersensitivity describes a type of unwanted immune reaction. Let's explore the rest of this scene to learn more. So if we're measuring kicking strength, we obviously need tees to hold the footballs. You see those Y-shaped kicking tees? Well, these Y-shaped tees kind of remind me of antibodies. Since antibodies are also Y-shaped. These Y-shaped kicking tees should remind you of antibodies, the main mediator of type 2 hypersensitivity. Type 2 hypersensitivity is specifically caused by antibodies directed against harmless antigens expressed on a cell's surface. These antibodies end up attaching to self cells, which can induce direct damage to the cell itself or impair its function. Let me explain how this happens using some high-yield examples. Notice how I've kicked this football so hard here that it has exploded. By the way, doesn't this red football kind of remind you of red blood cells? Since it's red colored and round, right? So this red ball exploding should remind you of hemolysis, since hemolysis just describes the bursting of red blood cells. Autoimmune hemolysis is a classic example of type 2 hypersensitivity. In this case, antibodies binding to antigens expressed on red blood cells. If you've seen our video on the immunoglobulins, you would know that antibody binding can effectively tag or mark cells for future destruction. This cell damage occurs through complement activation by the classical pathway, or antibody-mediated attack by NK cells. Since some antibodies also serve as opsonins, antibody binding to red blood cells can also make them more likely to be phagocytosed by macrophages in our spleen, also resulting in hemolysis. All in all, attached antibodies leading to cell death is the cause of hemolysis in both autoimmune hemolytic anemia as well as in acute hemolytic transfusion reactions. In these diseases, antibodies recognize and bind to antigens on red blood cells. Note that other examples of this antibody-directed cell damage include immune thrombocytopenic purpura, or ITP, in which platelets are targeted. Don't memorize the details here, focus on the big picture. Antibodies binding our cells can mark them for destruction. Next, notice when I kicked too hard, the shoes caught on fire because of the impact. Must be an electrical failure or something. Notice how my sensor shoes are actually up in flames. These flames should remind you of inflammation, another result of type 2 hypersensitivity. I mean, these shoes are definitely inflamed. Inflammation is usually caused by the release of cytokines that induce vasodilation, increased vascular permeability, and leukocyte recruitment. This manifests as the cardinal symptoms of inflammation, which include heat, redness, warmth, pain, and loss of function. This inflammation is related to the cell damage above, since cell death and complement activation leads to the release of inflammatory mediators. When antibodies don't target individual red blood cells, but rather organs at scale, we get inflammation in the tissue. Important examples of this include Goodpasture syndrome, rheumatic fever, pemphigus vulgaris, and hyperacute transplant rejection. You should review these diseases on your own, but in all of these cases, antibodies attaching to cells leads to inflammation, making them type 2 hypersensitivity reactions. Finally, notice the posts of the field goal over there. That was the initial goal of the sensor shoes, to measure the force of my kick into that field goal. By the way, don't the posts of this field goal remind you of a receptor? Since a receptor is often drawn to look like this field goal in biology. This should help you remember that another manifestation of type 2 hypersensitivity is binding of receptors by antibodies, which impairs their functionality. The most classic example of this is myasthenia gravis, in which antibodies bind to and block acetylcholine receptors on the motor end plate of muscles. By doing this, these antibodies prevent the muscle from contracting in response to neural impulses. This leads to the symptoms of myasthenia gravis, which include muscle weakness and paralysis. I want to note that antibodies don't always have to block the receptors they bind to. For example, in Graves' disease, antibodies bind to and activate the TSH receptor on the thyroid, resulting in hyperthyroidism. In both myasthenia gravis and Graves' disease, antibodies binding to receptors is the cause, making them type 2 hypersensitivity reactions. Alright, that's it for type 2 hypersensitivity reactions. Let's recap quickly and take a break from the training. Type 2 hypersensitivity reactions are a type of unwanted immune reaction caused by antibodies. Specifically, antibodies recognize and bind to antigens expressed by our own cells. The result of antibody binding causes three things: direct cell death and lysis, inflammation, or impaired function if the antibody targets a cell surface receptor. Antibodies can directly cause cell death in many ways, including complement activation or NK cell mediated damage. This can manifest as hemolysis in diseases like autoimmune hemolytic anemia or acute hemolytic transfusion reactions. Antibodies can also bind to cell surfaces and induce local inflammation. This inflammation is the result of complement activation or cell death releasing inflammatory mediators. Think of diseases like Goodpasture syndrome or rheumatic fever as specific examples here. Finally, antibodies can bind to receptors and impair function by activating or blocking their signal. This is the pathogenesis behind myasthenia gravis and Graves' disease. And we're actually done with type 2 hypersensitivity. See you at practice tomorrow.